Hi, good morning. Today we're going to solve differential equation. So let's take a look at the question. We got dy dx equal to e to the y plus x. And we need to find a solution to the differential equation with the initial condition y of 0 equal to negative ln 4. So let me copy the question over. So we need to do a step number 1, separate variables. So the variables are x and y, so they are in the exponent. So I'm going to do e to the y times e to the x. E to the y times e to the x. So it's like e squared times e to the third power equal to e to the 2 plus 3. We go backward. So you get y plus x exponent. So now you get e to the y times e to the x. So next step, I'm going to multiply the dx to the right side. So I will get dy equal to e to the y times e to the x times dx. I do not want the e to the y over here, so I am going to dy e to the y both sides. So now I let this cancel out, so I will get e to the x times dx. And here 1 over e to the y times dy. Step 2, we're going to use the integral symbol and then integrate. Now we're going to use the integral symbol and integrate. So over here, I'm going to rewrite e to the negative y times dy. On the right side, do e to the x dx. So let's take care of the right side first. So we add the entire derivative of e to u. You get e to u plus c. So you get integral e to the x. So therefore, it will be e to the x plus c. Now let's take a look at the left side. We get negative y. So we're going to make u equal to negative y, du equal to negative dy. So over here, we need to have a negative sign. So over here, we times negative 1, and then times negative 1. Negative, negative, cancel each other out. So over here, we got negative integral e to the u. Negative y becomes u. Negative y times negative 1, this is matching this, so become du. So now we continue. Negative stay the same. The entire due to e to u is e to the u. So now we got negative e to u equal to e to the x plus c. We are going to rewrite into negative e to the negative y equal to e to the x plus c, because we want to solve for y. It will be the next step. And then we need to isolate the y. There's a negative sign over here. So I'm going to multiply negative 1 both sides to cancel the negative. So it becomes e to the negative y equal this distribute, you get negative e to the x minus c. So how do we eliminate the e? We know that ln e to the something will cancel. So now we have to do ln e to the negative y equal ln, and this is going to be 2 terms. So I'm going to put inside the parenthesis. So we get ln e cancel out, and then we get negative y equal to ln of negative e to the x minus c. So we still have to give out the negative sign. So therefore you divide by negative 1 both sides. So y equal to negative ln so we got the general solution. To find a particular solution, we have to use y at 0 equal to negative ln 4 that was given. So when x equals 0, y equal to negative ln 4. So we put negative ln 4 equal negative ln, and then you replace x by 0. They are both negative, so divide by negative 1 both sides. So we get ln 4 equal to ln, and this I got simplified a little bit, e to the 0. Then the 4 and minus 1 minus c match. So we say 4 equal to negative 1 minus d. And then we plus 1 both sides. So you get 5 equal to negative c. C equal to negative 5. So the particular solution, so we go back over here, we replace the c by negative 5. So y equal negative ln, and you get negative e to the x, negative c, and c is negative 5, so therefore become plus 5. So we found the particular solution. So we finished question number 1. So now let's take a look at question number 2. Question number 2, we get dy dx equal to e to the x minus y. Find solution. Y equal to f of x to the differential equation to satisfy f of 0 equal 2. So we get dy dx equal to e to the x minus y. So step number 1, we're going to separate the variables. So the x and the y are both in the exponent, so we're going to rewrite it. Same base, you add the exponent. X plus negative y equal x minus y. Now we're ready to multiply the dx to the right side. And we still do not want e to the negative y over here, so we divide. So now we're going to get integral 1 over e to the negative y times dy, and this cancel out, so we get integral e to the x dx. So now we're going to integrate. So this side, you might want to rewrite it. Okay, so let's recall what we did before. So if you had 1 over 4 to the negative 2, it's basically 4 squared. Okay, you can check it. So we're going to rewrite into e to the y dy integral. So after that, we are going to integrate. So on the right side is much easier. So we're going to say e to the x plus c. And here is easier than the previous question. So integral e to the y dy, so basically e to the y. And plus c, but we're not going to write it because we already write it on the right side. So now we want to eliminate the e to solve for y. So we do ln. So this cancel out. So we get y equal to ln of this. So now we're going to use the f of 0 equal to 2. That's the initial condition. So when x equals 0, y equal 2, so 2 equal to ln, and then we got e to the 0 plus c. And then we simplify it, so we got 2 equal to ln, e to the 0 is 1. And how to undo ln? So we use e. So we got e to the 2 equal e to the ln 1 plus c. So this cancel. So we got e squared equal to 1 plus c and minus 1. So you got c equal to e squared minus 1. So the particular solution, so we go back over here, this one, and we have y equal ln minus c e to the x, and plus c is e squared minus 1. So we're going to write e squared minus 1. So this will be the particular solution. So we just finished question number 2. Let's go to question number 3. Question number 3, we have to find a solution to this differential equation, and the initial condition is f of 0 equal to half. So you got dy dx equal so now we are going to multiply the dx to the sign, okay, or cross multiply, see how you see it, because you have e to the 2y over here. Okay, so let's do this step and let's see if you see what I see. And then I want to eliminate the e to the 2y, so I have to multiply to this side. So basically it comes from the cross multiply. You can do it in one step. So now we do integral e to the 2y dy equal to integral 3x squared times dx. Now let's take a look at the right side. Okay, the right side is much easier to handle. So 3 times the exponent is 2, so it becomes 3 and then divided by 3 and plus c. So we simplify it, so we got x cubed plus c. Now I go back to the left side. I have e to the u, so that means u equal to 2y. So du equal to 2 times dy. So I need a 2 over here. So times 2. And then it's a times a half in the front to balance it. Okay. So now we are going to rewrite it. So you get 1/2 integral 2y become u, so e to the u, and then dy times 2 is du. Okay, so now we continue. 1/2 stay the same. So e to the u, we know that the entire derivative of e to u is e to u, so times e to the u. And I'm going to rewrite it because u is 2y. So now we had 1/2 over here. We need to solve for y. So I need to eliminate the half. So I should multiply by 2 both sides. So this cancel. I got e to the 2y equal. This multiply, I get 2x cubed plus 2c. Okay, so we're almost there. So I'm going to let k equal to c. I got e to the 2y equal to 2x cubed plus k. So I need to eliminate the e over here. So what should I do? I need to do ln of e to the 2y because the inverse function, and ln of 2x cubed plus k. Now this cancel, so I get 2y equal ln, this is 2x cubed plus k, and divide by 2. So we finished the general solution. Now let's take a look at the initial condition, which is f0 equal to half. So we're gonna say 1/2 equal and then we found out the numerator match, the denominator match. So we say 1 equal to ln of 2 times 0 cubed plus k. Okay, when the denominator match, the numerator also match. So we got simplify a little bit. There'll be ln of k. So some people already know that, okay? So we know that ln e equal to 1. So k had to be e. So if you do not see that you still can do e both sign cancel, you will get the same answer. Okay? So maybe some people say 1 equal to ln k. E to the first power, e to the ln k. This cancel, I get k equal e. Alright, so either way you get the same answer. So now the particular solution. So we go back over here, we get this. So we get y equal ln, okay, 2x cubed plus e. Okay, and then divide by 2. So we finished question, so that is the answer. So when I was checking the homework for some people, I noticed one thing. Alright, so if you have ln, for example, x plus 2, we cannot multiply ln to each, okay? ln of x plus 2 is not equal to ln x plus ln 2. This is not equal to. You cannot do that, okay? So there's something that you have to remember. You cannot distribute ln. This is a function of ln of x plus 2, okay? So just like if you have a sine, okay, of x plus pi, you cannot multiply into sine x plus sine pi. That is wrong, okay? You cannot do that. It's not correct. Okay. So I just want you guys to remember this. This is a function. You don't multiply, okay? All right, so we finished today's lesson.